Good morning, Nana.
Good morning, sir.
Good morning. Okay, na?
లేదు సార్. వాయిస్
Right?
సరిగ్గా లేదు.
Huh?
వాయిస్ చాలా లోగా ఉంది.
లోగానే ఉందా?
అవును సరే, లోగానే ఉంది.
ఏంటబ్బా? హే రామా. సేమ్ యాజ్ సిస్టమ్.
ఏంటి సార్?
సేమ్ యాజ్ సిస్టమ్ అలాగే. ఇప్పుడు
అలాగే ఉంది సార్.
ఏం చేద్దాం ఇక మనం ఇప్పుడు? నౌ
సార్ చెప్పండి సార్, వినిపించలేదు అక్కడ.
హలో ఇప్పుడు
లేదు సార్, అలాగే ఉంది.
ఇక మనం ఏం చేయలేం రా దీనికి ఇక.
ఇప్పుడు పెరుగుతాం.
పెరుగుతుందా?
ఆ,
ఓకే రైట్ గుడ్. అమ్మయ్య గుడ్. కమింగ్ టు హియర్ ఇక వాట్ టు స్టార్ట్ టుడే. ప్రీవియస్గా హౌ మెనీ అప్లికేషన్స్ ఆర్ ఓవర్ రా? ప్రీవియస్లీ హౌ
సార్
మెనీ?
17 అనుకుంటా సార్.
ఓకే అనుకుంటాను.
ఒక్క నిమిషం సార్, చెక్ చేసి చెప్తున్నా.
ఓకే
19 అయిపోయినాయి సార్.
గుడ్ మార్నింగ్ సచిన్ రెడ్డి. 19 అయ్యా? ఓకే ఓకే రైట్ రైట్. సరే ఓకే. 19 till ఓవర్ అంటే వీ హ్యావ్ టు స్టార్ట్ అప్లికేషన్ 20. While solving we while solving we found any new models, Nana, from the assignment? I think no new models. Am I right? Era, are you able to hear my voice?
సార్ ఒకసారి అని మాట్లాడండి సార్. నేను కొత్త డివైస్ నుంచి వచ్చాను ఇప్పుడే.
ఓకే ఓకే ఇప్పుడు వినపడుతుందా?
లైట్గా ఉంది సార్, అంటే తగ్గిపోయింది కొంచెం, కానీ వినిపిస్తుంది.
రామ ఏంది ప్రాబ్లం?
అవును సార్, అలాగే ఉంది. లైట్ గా ఉన్న వినిపిస్తుంది సార్.
Low, sir. It's very low, sir.
వెరీ వెరీ లో.
Means little audible, sir, but you continue, sir. I'll try to put on earphones.
That's better.
Yes.
Now
Same like that, sir. Previous. No problem, sir. You continue. It's clear. Means there's no like stuttering or something. It's clear, but voice is less.
okay okay. And now also same. Are you finding out same level of volume or
సేమ్ సార్, అంటే
ఏం పెద్ద ఇంప్రూవ్మెంట్? నో
నో
ఇంప్రూవ్మెంట్.
సార్.
సరే ఓకే
అంటే ఇయర్ ఫోన్స్ పెట్టుకుంటే మీది వినిపిస్తుంది సార్.
ఓకే ఓకే దట్స్ బెటర్. ఆల్ ఆఫ్ యూ గో
Yes,
విత్
sir.
ఇయర్ ఫోన్స్ నాన్న, దట్స్ బెటర్. ఓకే రైట్. Come to here application 20. In this application, Anna, this is very important model. Okay, which one? What I am going to discuss. Very important. Many times given in exam, in all types of exam. Okay, including advanced mains, BitSat, MSat, everywhere. Okay, they have touched this model. This is important model called as lens displacement method, Nana. And you have one experiment on this also. Lens displacement method. Okay. In this lens displacement method, if you observe, particularly for a convex lens, okay, lens displacement method of convex lens. Okay. If you observe the minimum distance between the object and image Anyone identified from the table? When the image is real, okay, when the image of a real object, comma, for a convex lens is real, then the minimum distance between the object and image is, do you know this point?
ఏంటి సార్?
క్వశ్చన్ అంతా అయిపోయాక ఏది సార్ అంట కదా.
డూ యూ నో దిస్ పాయింట్ అంటే ఈ పాయింట్ ఇప్పుడు మీరు రాసిందా?
దిస్ వన్ వాట్ ఐ రోట్ హియర్.
నో సార్.
నో. ఒకసారి చెక్ చేసుకో టేబుల్. when u is equals to infinity, v is equals to f. Am I right?
Yes sir.
Okay, and the object is at infinite distance, image on the other side at a distance of f, and the distance between object and image is infinity plus f, approximately infinity.
Yes sir.
This is actually called as maximum distance between object and image. Okay.
Okay sir.
And if you bring
Sir, minimum 4F, huh?
Yes, that's what I'm asking. Okay, minimum distance is exactly 4F. When the object is taken at 2F, image is at 2F, so that the distance between object and image minimum distance is 4F. Okay, if you want to check it, you can check it. What is there? Suppose the next possibility thing, u is greater than 2F. Any value you say u is equals to 3F. You can check 3F is greater than 2F only. Okay. If you use that 1 by v minus 1 by u minus 3F, clearly I mentioned the object is real object. Okay. Is equals to, you will get 1 by f, so that 1 by v is equals to 1 by f plus 1 by 3F. How much is this, Nana?
4 by 3F. 3 by 4F.
Means 3 by 4
1 by f minus వస్తుంది.
0.75F. అంటే here distance between object and image means u plus v on all the times. This is 3.75F kadra.
Sir, it is 1 by f minus 1 by 3F.
Oh, sorry. Here I have to take minus.
Yes sir.
Then how much is this? 3F by 2. Am I right?
Yes.
Yes sir.
Yes, sir.
This is 1.5. Is it right?
Yes sir.
Yes sir.
1.5 plus 3F.
4.5F.
That's what I'm saying. This is 4.5F. Okay. Just keep in mind, maximum distance already you found here. That is infinity only. Maximum distance is infinity between the object and image. Okay. When the object is taken at infinite distance, and when the object is taken at u greater than f, you got u plus v is equals to 4.5F. Okay. In next page I am taking on the same side here, right side, I am taking, if u is equals to 2F, no need to calculate that, all of you know, many times we use it in numericals also. V equals to 2F, so that the distance between object and image is 4F. But we don't know it is minimum or something. That's why just keep it in box and check it. Okay. Next possibility, Nana. If u lies in between F and 2F.
Less than 2F.
U lies in between F and 2F. I think no need to check, Nana. Okay. V is how much? Like reverse case if I take, Nana. If u is equals to 1.5, v equals to how much you get?
3F.
Same, without wasting the time, can I take the same thing in reverse, Nana?
Yes, sir.
Yes.
So here I am taking, say, u is equals to 1.5 f, lies in between f and 2f. Then I will get v is equals to, that implies v equals to, I will get 3f. Again, in this case, I am getting u plus v is equals to 4.5f, which is greater than 4f. Okay, even here also greater than 4f. Okay, this is already greater than 4f. Okay, Nana? So this one also you keep it in box, right? And what is the last possibility for real image? If u is equals to f, then v is equals to, Nana?
Infinity.
Infinity.
That implies u plus v is equals to, again, f plus infinity, approximately infinity only. Again, this is the maximum distance between object and image, between the object and image. And you should not take u less than f. Why you should not take that?
Sir, virtual image form అవుతుంది సార్.
I clearly mentioned in case of real image only, not virtual image. So these are the possibilities, Nana. All possibilities we checked. In all possibilities, where you are getting the minimum value here, 1, 2, 3, 4, 5. This is maximum. This is greater than 4f. This is greater than 4f. This is maximum. So exactly equal to 4f, only in one case you are getting. That's why it is the minimum distance between the object and image. So is it clear, Nana?
Clear, sir.
That's why here, if I want to fix the position of object and fix the position of screen and want to see the image on the screen all the times, okay, then here all the times on the screen image is formed means, can I say u plus v is fixed? Am I right?
Yes, sir.
Here first we write minimum distance between the object and image is 4f. Okay, so I have to take, to form the image on the screen, the distance between object and image, this distance from here to there. Okay, how much at minimum I have to take, Nana?
4f.
This minimum distance should be 4f. Okay, minimum distance 4f means to get the image on the screen, surely I have to take the lens at a distance of 2f. Okay, then here this distance will be 2f and the image is formed on the screen. First you understood the explanation here what I gave, Nana? Is it clear?
Yes, sir.
Clear, sir.
Yes, sir.
Or little bit clumsy?
Yes, sir.
No confusion anyway. Sure.
Sure, sir.
Okay, good. Then here what I am asking, I want to displace the lens from the position, from one particular position. Okay, but the distance between object and image is fixed. Okay, this is suppose L, if I take it as L. Okay, if L is fixed, okay, where L minimum is 4f, L is fixed, and by displacing the lens, okay, one student wants to get two real images on the screen, okay, then can I take L greater than 4F, Nana?
Sir, two real images రావడం ఏంటి సార్?
ఓరి పిచ్చి పడుతాయి ఇంత ఎక్స్ప్లెనేషన్ చేసిన తర్వాత అట్లా అడిగితే ఎట్లరా?
టూ రియల్ ఇమేజెస్ అంటున్నారు కదా సార్.
నేను ఏమన్నాను? బై డిస్ప్లేసింగ్ ద లెన్స్.
ఎస్ సార్.
అంటే లెన్స్ ని డిస్ప్లేస్ చేస్తే ఎట్ వన్ పొజిషన్ యూ షుడ్ గెట్ వన్ రియల్ ఇమేజ్.
ఓకే ఓకే అలానా. ఓకే సార్,
యూ షుడ్ గెట్ సెకండ్ రియల్ ఇమేజ్.
అర్థమైంది సార్.
డిస్ప్లేస్ చేస్తూ ఉంటే ఎట్ టూ డిఫరెంట్ పొజిషన్స్ యూ షుడ్ గెట్ టూ రియల్ ఇమేజెస్.
అర్థమైంది సార్.
అంటే ఎట్ అన్ ఇన్స్టెంట్ నాట్ టూ రియల్ ఇమేజెస్.
అదే సార్ అర్థమైంది.
Two better I write here. To get two real images at two different positions. ఇప్పుడు క్లియరా? At two different positions. Now is it clear, Nana?
Clear, sir.
Right. At two different positions on the screen. L should be greater than 4.
Yes, sir.
ఇక్కడే in this explanation only you can see here.
Yes, sir. ఒకవేళ లెస్ దాన్ అయితే మనకు వర్చువల్ వస్తుంది.
వర్చువల్ వస్తుంది. మినిమం ఆల్రెడీ కన్ఫర్మ్డ్ హియర్ ఆన్ ద రైట్ హ్యాండ్ సైడ్. ఓకే, అండ్ ఇఫ్ ఐ టేక్ L ఈజ్ 4.5F, ఇక్కడ ఎక్స్ప్లెనేషన్లో ఉంది, రైట్ సైడ్ ఎక్స్ప్లెనేషన్లో. ఏనా ఆల్ ఆఫ్ యూ అండర్స్టూడ్ దట్?
Yes, sir.
L is equals to 4.5F. Okay, at one position U is equals to 3F. And suppose lens is here at one position, which is 3F, and V is 1.5F. I will get one image. Correct, Anana?
Correct, sir.
Yes, sir.
And 4.5F, I am getting U plus V at some other position also. This time U is 1.5F and V is equals to 3F. And U is less, and here for first position I am getting somewhere here where U is 1.5F and V is 3F. I am getting one image. And U is equals to 3F, V is equals to 1.5F. I am getting the second image. Is it clear, Nana?
Clear, sir.
Clear, sir.
Clear, sir.
Try to understand one more point, and you have to understand in my explanation. Okay, first position I told U is equals to 1.5F, means U1 is 1.5F, V1 is equals to 3F. Correct, Anana?
Yes, sir.
Correct, sir.
Second time, second position, U2 is 3F and V2 is equals to 1.5F.
Yes, sir.
Means what you understood?
Lens is this.
U1 is equals to V2, U2 equals to V1.
Yes.
At the two
Yes, sir.
positions. Understood?
Yes, sir. Yes, sir.
So can I write that in the next page, Nana?
Okay,
Or do you
sir.
have any doubt in this?
No doubt, sir.
Good. So I am going to
No
the
doubt.
next page. Thank you, Nana. In the next page, I am writing here. Oh, sorry. Here I am writing. In case of L is greater than 4F, okay, at the position 1, okay, I write 1 by V1 using the sign conventions now, plus 1 by U1 minus of minus plus equals to 1 by F or F1. I am
Sir,
using at the
F only, sir.
F only. Why? Because at the two positions
Same
I am
lens.
using same lens. Very good, very good, very good. And at the position 2, can I write here 1 by V2 minus 1 by, that is plus 1 by u2 after using the sign convention is equals to same 1 by f. Okay, where v1 is equals to u2 and v2 is equals to u1. Will you accept this one, Nana?
Yes, sir.
Or do you want any explanation?
No, sir.
Very good. I think all of you understood. I already explained with one example here. Okay. And suppose if I ask in which position you will get the magnified image, either position 1 or position 2. Simple, you can say.
V greater
Sir,
than
one,
u.
sir.
V1.
Position one,
V1.
one.
V1 by u1.
Yes.
First
In first
position.
case, v1 is greater than u1. That's why in first case you will get magnified image. Second case, will you get one or diminished image?
Diminished, sir.
Diminished, sir.
Very good. So can I write the next point here? In the two cases, m1 is
Sir?
equals
Sir, always like if we take any two positions of greater than 4f, like L greater than 4f, always this condition will be true, sir. V1
yeah,
equal to
that's
u2.
what even from here also you can say, Nana.
Okay,
Why?
okay,
Because
sir.
here right hand side you should get same value.
Yes,
Go to
sir.
mathematics like 1 by 3 plus 1 by 4. How much is this?
7 by 12, sir.
7 by 12.
Yes, sir.
Second time I have to get 7 by 12. Say the two values here, different values.
We can't say, sir.
You can't say. They must be 1 by 4 plus 1 by 3 only.
Yes, sir.
Means the two values are interchanged here or not? Means v1
Yes, sir.
is v2 is equals to u1.
Okay,
And
sir.
v1
Yes,
is
sir.
equals to u2. Am I right?
Yes, sir. Yes, sir.
Even from mathematics also you can say. But
Okay.
being a physics lecturer, I explained with the physics here using this
Okay.
logic.
Okay, sir.
Right.
Okay, sir.
Good. So come to here. In the two cases, magnification, that is minus first case v1 by u1, which is greater than 1, and m2 is equals to second case minus v2 by u2, which is less than 1. It is enlarged and it is diminished. Okay, Nana? And can you say something from m1 and m2? By multiplying, I think will I get 1 or something, Nana, here? Magnification?
Yes, sir. Sir.
Why? Because if
One,
I take,
sir.
m1 into m2 is equals to 1. Okay? Don't mislead, Nana. In mathematics, m1 into m2 is equals to minus 1, then the two straight lines are perpendicular to each other. Am I right?
Why, sir?
In a pair of straight lines, sir.
Yes, sir. But why we connect over here, sir?
Generally, you are a mathematics student, na? So m means immediately you recollect instead of here the magnification slope. There also represent with m only, na?
Yes, sir.
m1 into m2 how much in lens displacement method means immediately the student tries to say that is minus 1, sir.
Okay, sir.
Why yes, sir, two straight lines are perpendicular to each other, the product of slopes is minus 1, sir.
Okay, sir.
So m1 into m2 is equals to 1 here. So is it clear, Nana?
Clear, sir.
Right.
Yes.
Right. This is one formula in numericals we use, and try to remember these formulae also in numericals, particularly in lens displacement method we use. And of course, I think all of you understood this v1 is equals to u2 and v2 equals to u1. And keep in mind the two here slopes in the two positions. Okay. And next I am asking, suppose here, not suppose, here really the lens is displaced from position 1 to position 2. Okay. And here this displacement from 1 to 2, it is the displacement. Am I right, Nana, in my diagram? 1
Yes.
to 2. that displacement, suppose if I take it as d, okay, that's what I'm writing here. Next point, in this method, if the displacement of lens, okay, is d, that is between first and second positions, okay, then from the diagram can I write u1 plus d plus v2 equals to L, correct?
Yes, sir.
And u2, okay na, follow అవుతున్నారా?
Yes, sir.
రైట్ సరే, ఇలా అంటే ఇంకా ఈజీగా
Okay.
అర్థమవుతుంది. u2 plus v2 equals to L, u1 plus v1 equals to L, and u2 minus u1 is d.
Yes, sir.
Correct?
Yes, sir.
v1 minus v2 is d.
Yes, sir.
All my statements correct or wrong?
Correct, sir.
Good. Then here those statements I am writing in the next page. Okay, Nana? Is it raining in Hyderabad?
Yeah. నిన్న పడింది సార్.
ఇప్పుడు పడట్లేదా? మాకు ఇక్కడ పడుతుంది. Okay, right, no problem. What the statements I told there, Nana? That implies u1 plus v1 equals to L and u2 plus v2 equals to L, two statements. And ఇక్కడ ఏం చెప్పాను నాన్న? మర్చిపోయారా?
v1 minus
very good. v1
minus v2.
v1 minus v2 equals to d and u2 minus u1
d.
Right. v1 minus v2 equals to d and u1, sorry, u2
sir, u2
minus u1 equals to d. ఇప్పుడు can you interlate the terms here, any two? అంటే ఫర్ ఎగ్జాంపుల్ సింపుల్ ఇలా అడిగితే మీకు ఇంకా ఈజీగా అర్థమవుతుంది. సపోజ్ ఇఫ్ ఐ ఆస్క్ u1 u2 values or v1 v2 values, can you say them?
Yes, sir.
అంటే in terms of d, yes.
In terms of L and D.
Sir.
చెప్పచ్చా?
చెప్పొచ్చు సార్.
ఎలా?
u1 v1 సేమ్ కదా సార్. ఇప్పుడు ఆ రెండింటిని యాడ్ చేస్తే క్యాన్సిల్ అవుతుంది.
ఆ లాజిక్ వెళ్ళాలి. v1 is equals to u2 and v2 equals to u1. Oh, sorry. v2 equals to u1. v2 equals to u1, if you substitute here, v1 minus u1 equals to d, correct?
Yes, sir.
Whereas v1 plus u1 is L. You can solve. Or from this what can you write? u2 equals to v1. u2 equals to v1 means can I write it as v1 again minus u1 is equals to d, correct Nana?
Yes, sir.
లేదు u2 సార్ సెకండ్ ఈక్వేషన్కి రిలేటెడ్గా రాయండి సార్. ఓకే, నో ప్రాబ్లం. I write related to the second equation.
u2 minus v1.
u2 minus u1 I write it as
v2.
u1 is
v2.
Good. u1 is, sorry, u1 is v2 equals to d. I think by solving the first two equations and the next two equations you will get v1 v2 u1 and u2. Being a mathematics student, directly tell what is u1.
Sir, 2v1 is equal to L plus D, sir.
Right.
L plus d by 2.
Which is L plus d by
U v1, sir.
v1. Okay.
v1
is equals to, you are telling that L plus d by 2. Very good. Then what about u1?
L minus d by 2.
Very good, excellent, Nana. L minus d by 2, where u1 is equals to v2, Nana, in lens displacement method. So this is obviously equals to, or v2 equals to L minus d by 2. Here, or v1 is equals to whom?
u2.
U2, sir.
So u2 equals to L plus d by 2. Okay, so try to keep in mind these two equations here. Okay, Nana, better I take next another color. So here take it, these two equations, and these two equations we get from where, Nana? From here.
Sir,
Yes.
sir, in starting we wrote right now, sir, minimum distance between the two lenses is 4f.
Yeah.
Means, sir, if suppose it is like less than 4f, sir, then always
Less
if we
than 4f.
means like
Less than
suppose
4f, you only.
means always if we change the displacement, then we won't get clear image, na, sir. Means we won't
In the
even
middle
form
you
the
won't
image.
get in the middle you won't get clear image. That's why to get the clear image only I moved from 1 to 2.
Okay, sir. Okay.
Means in
Clear,
the middle
sir.
I am not getting clear image. This is here you will get some image, but that is blurred.
Okay, sir.
That's why I
Okay.
searched for the clear image. I got it at the position 2.
Okay, sir.
There only you
Clear,
can
sir.
understand. Oh, by just interchanging the values only we are getting the clear images here.
Okay, sir. Clear, sir.
Understood? Right.
Yes, sir. Clear, sir.
Right. So here better I draw the two images. This is I1 and another one enlarged I2. Okay. So this is, I take it as U1 less and this is I1. U2 is more. So the diminished one is I2. Okay. Is it clear in the diagram, Nana? Better.
Yes, sir.
I take any another color. Better I go with another color. This is I2. Correct, Nana? This is I2 and it is I1 in the diagram. Okay, good. Then here if I ask, after finding out U1 V1 or U2 V2, if I ask the focal length, then will you use this formula, Nana?
Yes, sir.
Yeah, coming to the last formula in lens displacement method. Now I am coming to here. That implies 1 by V1 plus 1 by U1 equals to 1 by F. I am going to substitute these values. 1 by V1 is 2 by L plus D. Okay, plus 1 by U1, that is 2 by L minus D equals to 1 by F. Then by taking LCM, how much you get there? Directly you tell F is equals to how much? Don't say any
4L by L square.
Huh?
L square minus d square by 4L.
Yes,
Very
sir.
good. This is correct. L square minus D square by 4L.
4L.
Good. After taking LCM and reciprocating the equation. Correct, Nana?
Yes, sir.
Right. This is the focal length. What the lens you used in lens displacement method. Okay, Nana? They may ask, find out the focal length in lens displacement method. So these many equations are there only in one method, Nana. All these are related to only one method. Okay. So here first major condition, fixing the distance between the image object and screen. First condition, you have to take L should be greater than F, 4F. Okay, fundamental condition. You fix it. Suppose F is some 20 centimeters. Better you go with more than 80 centimeters, like 90 centimeters, 100 centimeters. We take in lab experiment. I am telling Nana. Okay, generally we fix the screen position and object position both. We fix like a candle and the white screen. Generally, usually we take at 100 centimeters if focal length is 20. Then we start the experiment. Okay, In that experiment, what are the possibilities here they ask in exams, sir? They may ask here the magnifications, means you have to find out V1 and U1, Nana. From here, can you say what is the magnification in first case and what is the magnification in second case, Nana?
Yes, sir.
Yeah, you tell here what is the magnification. M1, next point. M1 is equals to V1
minus
by U1.
of L plus D by 2 whole by.
1 minute, please. Anything missed here? Nothing. Okay. M1 is
Sir,
equals
minus
to V1 by
of L
U1.
plus D by L minus D, sir.
Ante V1 by U1. L plus D by L minus D. Of course, that magnification is negative. Why? Because real and inverted. This is M1. M2, I think no need to say. Am I right?
Yes, sir. Reciprocal.
Reciprocal. M1 into M2 is equals to 1. That's why here M2 is minus of L minus D by L plus D. L minus D by L plus D. Okay. So using these things, you try to calculate whatever they ask in exam. Okay. Good. These are the equations here we derived from lens displacement method. Okay. Now last but not least, we write if L is less than 4f, what happens? Okay. So last point here we are writing if.
Sir, one virtual, one real వస్తుందా?
వస్తుందిరా. రియల్ రావాలంటేనే మినిమం డిస్టెన్స్ హౌ మచ్ ఐ ఆస్క్డ్ మిమ్మల్ని అడిగింది
2f మినిమం 2f
మినిమం 2f కాదు 4f.
అవును సార్.
మినిమమే 4f అంటే దాని మీనింగ్ ఏంది? ఇఫ్ L ఈజ్ లెస్ దాన్ 4f యూ వోంట్ గెట్ ఎనీ రియల్ ఇమేజ్ కదా.
అవును సార్, అర్థమైంది.
మినిమం ఈజ్ 4f టు గెట్ ద రియల్ ఇమేజ్, దట్ టు వన్ రియల్ ఇమేజ్. 2 రియల్ ఇమేజెస్ కావాలంటే వీ హ్యావ్ టు టేక్ L గ్రేటర్ దాన్ 4f. అర్థమవుతుందా నేను చెప్పేది? ఏమైనా కన్ఫ్యూజింగ్గా ఉంది?
అర్థమైంది సార్, క్లియర్గా.
రైట్, గుడ్. సో హియర్ ఐ రైట్ బెటర్ అండర్ నోట్. Okay, here I write note number 1. If L is less than 4f, what happens? Okay, L less than 4f, only one virtual image is formed. Virtual image is formed on the same side comma but not on the screen. Okay, any mistake in this statement, Nana? 1?
No sir.
Very good. And number 2, here if L is equals to 4f, okay, only one real image is formed on the screen. Is it correct, Nana?
Yes.
And third point, what we did the experiment here, if L is greater than 4f, then okay, by displacing the lens okay, real images, okay, 2 real images are formed, okay, at 2 different positions. This is what we wrote previously in the derivation. This is the story, Nana. Okay, by this we completed what the lens displacement method. So do you have any doubt in this, Nana? Ika, lens displacement method, can I wind up?
Yes sir.
Okay, right. So here nearly we took more than 3 pages for one app. Okay, app number 20 is over. Because we are coming to here, Next one, this is app number 21. Okay. In this case, suppose this is one lens, convex or concave, one lens, and as usual this is the principal axis. Okay, and it is the diameter as usual. Which one? This one is the aperture or diameter. Okay, yesterday in the assignment you did one model. If it is made of some mu1, one refractive index, numerical value given in the numerical, I think 16th problem in the assignment. Okay, and it is made of mu2, means the two parts, like two plano convex lenses. How many images are formed? Yesterday that question was not there in the assignment. Just he asked at one object position, what is the distance of image? Okay, therefrom after solving that numerical, try to understand how many images will be formed here. Will you get only one image for one object or two images for one object? With your knowledge.
Sir, one, sir.
Huh?
One.
Only one.
అంటే ఈ రెండు కలిసిన తర్వాత ఒక సింగిల్ ఈక్వి కాన్వెక్స్ కాకుండా మామూలు కాన్వెక్స్ లెన్స్ లాగా యాక్ట్ అవుద్ది కదా సార్?
ఎస్, అంటే హియర్ రిఫ్రాక్షన్ అండ్ ఓన్లీ ఇట్ ఈస్ కన్వర్జ్డ్ టు వన్ పాయింట్ హియర్ ఇమేజ్. Okay, even if you take the light ray from the bottom, that will come to the same point. So how many images are formed, Nana?
One, sir.
Means laterally the lens is made of two different materials. With the knowledge what we solved from the assignment, we can understand that only one image is formed here. Okay, same question, suppose if they change like this, again this is convex lens, okay, and this is the principal axis, okay, and here this is the aperture as usual, and but this time what I am doing here, the total upper part, okay, these two are made with mu1 and mu1, and the total lower part mu2 and mu2, means try to distinguish these two now. Here you are taking two different materials with respect to diameter. Here you are taking two different materials with respect to principal axis. So did you...
Sir, here two images will be formed, sir.
Why?
Because
upper part
the
నుంచి
focal...
వెళ్ళేది వేరే దగ్గర, కింద పార్ట్ దగ్గరికి వెళ్ళేది వేరే దగ్గర మీట్ అవుతుంది.
Very good. And here you
and
get... yes.
Sir, one more thing, because focal length will be different, sir, upper part and lower part.
Very good. Upper part focal length is different, lower part focal length is different. Okay, but here the total focal length will be same.
Yes, sir.
Very good.
Correct,
yeah,
same.
You are right. So suppose it is one light ray, this one and this is forming the image somewhere here, and another one is forming the image somewhere. Why? Because of different refractive indices, that is because of different focal lengths, what Mr. Aryan Kumar told. So maybe, I don't know, somewhere here the image will be formed. So here we are getting two different images. Here I1 and here I am getting I2. Okay, so here can I write two images are formed? Okay, here can I write the total lens has, okay, one focal length, one focus. Here can I say upper part and lower part have have different foci. Okay, understood this one, Nana?
Yes, sir.
In exam what he asked previously, ఇట్లాంటి థియరిటికల్ అన్ని ఇంపార్టెంట్ ఫర్ బిట్స్ ఎగ్జామ్ నాన్న. Okay, in BitSat what he asked previously, third one I am taking here. Okay, this is one lens as usual I am taking, and this is the principal axis, common thing, and it is the diameter. I am taking here, and then better I write here also, this is one and this is right, and here I am saying this is of refractive index mu1, this is of refractive index mu2. Okay, this is of refractive index mu3, and this is of refractive index mu4. Now you say how many images will be formed?
2 అని అనుకుంటా సార్.
2 na 4?
2 సార్.
2 సార్.
2 na?
2
Yes,
అంటే
sure, sir.
పైనది mu1 mu2 ఉన్నా కానీ ఒక సింగిల్ నాన్ ఈక్వి కాన్వెక్స్ లాగా యాక్ట్ అవుతుంది, కిందది అలానే సిమిలర్.
రైట్, mu1 mu2 అంటే లైక్ దిస్. ఓకే
సార్ కానీ ఇక్కడ సింగిల్ ఇమేజ్ ఫార్మ్ అయ్యే కేసు కూడా రావచ్చు సార్. అంటే మనకి
కాంబినేషన్ ఆఫ్ mu3 mu4, దట్స్
అది కూడా ఒకవేళ పైన దాంతో ఈక్వల్ అవ్వితే అప్పుడు సింగిల్ ఇమేజ్ అయిపోతుంది సార్.
అంటే అది అవ్వాలి అంటే వాట్ యు ఆర్ సేయింగ్, ద mu1 mu2 వాల్యూస్ mu3 mu4 వాల్యూస్ ఇంటర్చేంజ్ అవ్వాలి.
అవును సార్, అవును.
అంటే లైక్ mu1 is equals to mu4, mu2 is equals to mu3, what you are saying.
అవును సార్.
Right, good. In this case object is taken here, then two images are formed there, I1 and I2. Okay, upper part behaves as one lens, behaves as one lens, and the lower part behaves as another lens. Another lens. Okay, that is, it has two foci. Okay, that implies two images are formed. And we add that point what you told, if their refractive indices are interchanged. Okay, note, if mu1 is equals to mu4 and mu2 is equals to mu3, okay, interchange, or ఏదో ఇలా మెన్షన్ చేసిన mu1 is equals to mu3 and
mu2 equals to
mu4, then only one image is formed, correct ena?
yes sir.
Yes, sir.
Right, good. Ante, right, only one image is formed. Okay, this is final conclusion for today's class. Okay, Nana? Right. And not today's class, in the concept of lenses. Okay. So finally we completed the lenses part, Nana. Now you got some confidence, solve all the models
Yes,
related
sir.
to lenses.
Yes, sir.
Able to solve?
Yes, sir.
Okay,
Sir,
good. Nana.
sir, in this 21th application, sir,
Yes.
1 and 2 will have same focal length, no, sir?
1 and 2 means
First case, second case.
here.
Yes, sir. Finally, means both will have same focal length.
Oh, you are asking in the note.
No, sir. In 1 and 2, sir. First case and second case means if you will calculate net focal length of the whole lens, it will be equal, no, sir, for both the lenses. Means
Net focal length, when you calculate, Nana, finally if you get only one focal length, you
okay,
are
sir.
using 1 by
Okay.
f1 plus 1 by f2 is equals to 1 by f, means after adding you are getting only one focus.
Okay. In second, we are getting 2, sir. Okay.
Yeah, here it has two
Sir, ఇది
foci.
progressive lens type. Second.
This is like a progressive lens, Nana.
Okay, sir. Okay, sir.
Different parts. Okay.
Okay, sir.
That's why this preparation is hard, Nana. In progressive lens, what they take, the refractive index they change. Here different,
Yes.
here different, here different, here different, here different, like they prepare now. Okay.
Okay, sir.
They try to change the negative focal length to positive focal length by changing the parts here, the refractive medium.
Then, sir, 2 will be formed, no, sir. 2 images you told me.
If you
Means
see
on.
from bottom, observe, means suppose, I know that clearly. Why? Because I am suffering from both.
Okay, okay.
Suppose if I see from bottom, that one for actually hypermetropia.
Bottom part.
Bottom part.
Okay,
Means
okay, sir.
if I lower my eyes down,
Yes, sir.
and if I
Yes.
want to see from the lower part of the lenses,
Yes,
okay, whom the distant object,
yes, sir. We
then
can't see.
I can't see the image clearly.
Okay, sir.
From the top part, if I want to see the near object, I can't see.
We can't see. Yes, sir.
That's why you see who are suffering from hypermetropia, they suppose if you place one paper in front of them, old people, Nana.
Yes, sir. We can't. They can't see.
They can't see.
Generally.
Then what they say, they try to move the lenses far away from the eyes, and they try to tilt their head up.
Yes, sir.
Am I right?
Yes, sir.
We feel that they are seeing our face.
Yes, sir. But they are trying to look from.
They are seeing the paper actually.
Yes, sir. From bottom part of the.
They are trying to see from the bottom part.
Okay, okay, sir. Clear, sir.
Why?
But sir, generally we see from middle only, no, sir. Any object. If suppose.
If we see from the top part, Nana.
Okay, okay, sir. Means if suppose you only, sir, if you have both, no, sir, hypermetropia and my. Means sir, always means from up little upside you will see, sir. Everything
Little
means
upside.
every.
That's why I try to move the eyes a little bit forward, not close to the eyes.
Okay,
if
okay.
I move
Sir.
close to the eyes, I have to tilt my head a little bit down.
Okay, sir. Clear. Understood.
Yeah. This is the story, Nana, and lenses part is over from here, and we are almost turning to prism part is over, lenses part refraction, and we are coming to almost to the last part of our ray optics, moving into optical instruments now. Okay, so here moving into optical instruments.
Sir, we won't have working of eyes, sir.
Finally, Nana, finally I will explain that part. Like not complete working of eye, just myopia and hypermetropia we discuss.
Okay.
Not the cylindrical effects and all we want to discuss.
Okay, sir.
Optical instruments. In these optical instruments also we won't discuss about the working of camera, Nana. We won't discuss about the working of camera and binocular.
Okay, sir.
We discuss only two things, optical instruments. One is microscope, other is telescope. Only two parts we discussed.
సార్ టెలిస్కోప్ బైనాక్యులర్ కొంచెం సిమిలర్ కాదా?
సిమిలర్ అంటే అక్కడ దాని వర్కింగ్ కొద్దిగా డిఫరెంట్గా ఉంటుంది.
ఓకే
ఓకే, here this is what microscope one part is, means microscope is used to see the near objects, okay, and this is a telescope used to see the far objects. Okay, this is used to see the near objects. It is used to see the far objects. Means simple, I can say one example here to understand. To move to see the blood cells, okay, in blood test lab, they won't use telescope now. Why? Because they put the blood sample on the slide and they put very close to the optical instrument what they take, and they try to see the cells inside. Okay, already the object is close to our eyeballs, but blood cells we can't see directly. That's why we are taking the help of microscope. I think you understood what is the purpose of microscope.
Yes.
Even though the object is near and that object is not clear, like the instructions given in the mutual bonds, okay, like subjected to market risk, right? There we use to see the microscope like magnifying lens, nana, simple, okay, to magnify the size of object, means size of image.
Okay, sir.
Telescope used to see the far objects like the stars and all, okay. There to see the star means that will appear like a dot, nana. To magnify that far object we use the telescopes. Okay, basic difference I explained here, nana, between microscope and telescope. Why? Because for magnification, what the type of formula we are going to use is very important, nana, here in these optical instruments. That's why I took more time here. Okay, actually I did not waste your time. Okay, and here in the microscope and telescope, what actually you see? Suppose if I come to microscope, okay, microscope when we use, sir, really we never take the help of microscope, nana, until what, sir? Generally the healthy eye, this is suppose my eyeball, of course not my eyeball, healthy person's eyeball, okay, and that person without using any optical glasses, okay, spectacles, he can see the object clearly up to a distance called as least distance of distinct vision, okay, that is equal to this distance represented with the letter D. This is equals to 25 centimeters, nana, for healthy person, not for all. Okay, this is called
No.
as the near point vision. Okay, then you may argue, sir, even though if I bring my hand very close to the eyeball, let it to a distance less than 25 centimeters, now I am checking, sir, when you was explaining the concept, okay, here I already checked, sir, I am able to see the lines on my palm, sir. Yeah, correct. But that time, even though if you bring your hand close to your eyeball to a distance less than 25 centimeters, that time the eye will get some strain, nana. Means there inside the ciliary muscles which are connected to the eyeball, nana, they try to expand, try to open your eyeball, and you are giving lot of strain to ciliary muscles. Okay, so what I am saying, this is 25 centimeters near point vision without giving any strain to ciliary muscles. Okay, that's why we say it is called as a relaxed eye. So is it clear?
Clear, sir.
In the relaxed position, I told that without giving any strain to the muscles inside the eyeball, okay, and valves, water supply valves, anything, without giving any strain to anyone inside, the minimum distance is 25 centimeters. That is least distance of distinction. Okay. Even though suppose some object is placed at a near point, okay, that is not clear to the eyeball, then we use microscope now. And basically you have to understand this microscope concept is mostly related to what understood?
Yes, sir.
అర్థమైందా నా అందరికీ?
Yes, sir. Yes, sir.
Sir, last what you told, sir, little break it came, sir. Sir,
Okay, right. Last what I told, this microscope concept is completely related to the concept of least distance of distinct vision. That's what I told.
okay, clear.
Why? Because when we use the microscope even though the object is placed at a distance of 25 centimeters,
We can't see very clearly that time.
we can't see very clearly.
Okay, sir. Clear, sir.
Okay. That
Yes, sir.
time we try to magnify the size of object at this distance and try to see that clearly by using the microscope.
Okay, sir.
And
Clear,
everything we are discussing with what least distance of distinction.
Sir,
Okay, sir.
Yes, ma'am.
అంటే ఇప్పుడు ఒక మైక్రోస్కోప్లో ఐపీఎస్కి ఇంకా పెట్టే స్లైడ్కి 25 సెంటీమీటర్ ఖచ్చితంగా ఉంటుందా?
25 సెంటీమీటర్స్ కన్నా తక్కువ ఉంటుంది.
తక్కువనా?
తక్కువ ఉండి ఫైనల్ ఇమేజ్ మ్యాగ్నిఫై చేసి we try to bring that virtual image to a distance of 25 centimeters.
ఓకే సార్.
అర్థమైందా?
అర్థమైంది సార్.
Yes. Okay. Right. So is it clear, Nana?
Yes, sir.
Clear.
Yes, sir.
ఓకే. అంటే ఇప్పుడు నేను నీకు చెప్పింది ఏంటంటే మిస్టర్ నీహాన్, ఒక ఆబ్జెక్ట్ నాకు బాగానే కనపడుతుంది. సపోజ్ లెటర్ ఏ అనే
అర్థమైంది
ఐఎమ్
సార్.
ఏబుల్ టు సీ, కానీ దీన్ని 25 సెంటీమీటర్స్ కన్నా 10 సెంటీమీటర్స్ డిస్టెన్స్లో పెట్టాను. ఇప్పుడు ఇస్ ఇట్ క్లియర్ ఆర్ బ్లర్డ్?
బ్లర్ సార్.
ఇప్పుడు దీన్ని మళ్ళీ 25 సెంటీమీటర్స్ తీసుకెళ్ళి ఈ కొద్దిగా మ్యాగ్నిఫై చేసి చూడటానికి మైక్రోస్కోప్ యూజ్ చేస్తాం. వన్ కాన్సెప్ట్. ఓకేనా? నెంబర్ 2, సార్ ఈవెన్ దో ఐ ప్లేస్డ్ ద ఆబ్జెక్ట్ ఎట్ ఎ డిస్టెన్స్ ఆఫ్ 25 సెంటీమీటర్స్, మీరు ఏదో రాశారు సార్, అదేందో తెలియట్లేదు. నేను ఇప్పుడు రాసింది ఏంది?
ఏదో రాశారు.
అది అంటే క్లియర్గా కనపడట్లేదు కదా?
అవును సార్.
బట్ ఇట్ ఈస్ ఎట్ ఎ డిస్టెన్స్ ఆఫ్ 25 సెంటీమీటర్స్ ఆర్ మోర్ దాన్ 25 సెంటీమీటర్స్. నాకు అది కనపట్టలేదు సార్ దాన్ని. ఇప్పుడు దీన్ని మ్యాగ్నిఫై చేసి చూడటానికి సార్ రాసింది ఏనా? ఎస్. ఈవెన్ ఫర్ దిస్ పర్పస్ ఆల్సో వి యూస్ ద మైక్రోస్కోప్. అండర్స్టూడ్? ల్యాబ్లో యూస్ చేసేది ఇది కనపడదు కాబట్టి దాన్ని మ్యాగ్నిఫై చేసి చూడటానికి బ్లడ్ సెల్ ల్యాబ్లో వి యూస్ దిస్ కాన్సెప్ట్. ఓకేనా?
ఓకే సార్.
గుడ్. సో కెన్ ఐ వైండ్ అప్ ద కాల్ నౌ, నాన్న? Do you want any pages in the middle?
కావాలి సార్.
Okay, right. 1, 2, 3, 4. This is first page.
ఓకే సార్.
Second.
ఓకే.
Third.
ఓకే సార్.
Fourth.
ఓకే సార్.
Fifth.
ఓకే సార్.
Yes, correct, నాన్న. చాలా లోగానే ఉంది. క్లాస్ అంతా అయిపోయింది కూడా. Mr. Anish. Right.
Sir, this is last concept, sir, in this topic.
Almost, Nana. After completing these two, just we go through myopia and hypermetropia and we wind up this chapter.
How many chapters are left, sir, after this?
Physical optics there, waves I don't know about that. And
Only one.
Modern physics is there.
Okay, sir.
Modern physics means డ్యూయల్ నేచర్ ఆటమ్స్
సార్ ఎలక్ట్రిసిటీ ఇంకోటి ఉంది కదా సార్, ఏసీ కరెంట్ చాప్టర్ ఉంది కదా సార్.
ఇక ఎలక్ట్రిసిటీ అంతా సార్ చెప్తుంటారు, మన సంబంధం లేదు.
సార్ మీరు చెప్పండి సార్ ప్లీజ్ సార్.
ఓపెన్ మీటింగ్లో ఇలాంటి అడగకూడదు. ఓకే, ఇప్పుడు ఎక్కడ ఉన్నారు మీరు?
ఏమో సార్
అదేంద్రా
నేను చూడలేదు సార్ కొద్ది రోజులుగా.
Sir, we are in that, sir.
Torque, sir. Torque due to magnetic field.
అంటే మూవింగ్ ఛార్జెస్
Coil.
Coil, sir. అదే BIA sin theta.
BIA and sin theta, BIA cos theta. ఓకే, రైట్. అంటే ఇంకా MCC స్టార్ట్ అవ్వాలి.
Today we'll start, sir. Sir, today we'll start today.